So, hi, my name is Taro Omiya. I'm basically the developer at Omiya Games that makes a lot of Ludum Dare games. You can tell because I have a Ludum Dare tab on there. But yeah, outside of making a lot of Game Jam games, one thing that I do very often is teach about developing games on Unity. It's one of the game engines that I personally use the most often. By trade, I am a programmer. However, for this course, I'm keeping programming to an absolute minimum. And I'm also assuming that you have absolutely no knowledge to anything about game development. So a couple of things that we're going to be going over outside of how to use Unity is also some technical terminologies that are very common in the game industry, but obviously without prior knowledge to it, a lot of people are going to be drawing a blank saying like, what the heck does this mean? I'm going to be explaining some of that too. So without further ado, welcome to Crash Course Unity. I do have a file here that I should probably navigate to the proper location real quick, so give me a quick second. Right. So I usually make sure that you have this zip file already, and then I think, yeah, actually that's it. We just need to, that would be it. So welcome to Crash Course Unity 3D. Supplementary materials, I'm just gonna say this real quick. The official site on Unity for tutorials is actually quite extensive and really excellent, in my opinion. It is a game engine that kind of assumes that you know how to program, not necessarily from the perspective of like getting a prototype requires programming so much as getting a more like sustainable, getting a more solid game framework does require learning a little bit about C# programming stuff. It tries to keep it to a minimum, but nonetheless, it is something that, in my experience, I found that I rarely had a project where I could get away with not programming anything. But then again, I'm also a person that makes really complex games, so that's on me too. Whoop. Oh no, I skipped all the way to the end right there. Oh, I see what happened. Alright, there we go. So the goal of this lesson, getting comfortable with a Unity game editor. So yeah, basically it's about learning how to use, it's just, Unity itself is a very large program with a lot of features onto it. I'm not going to be able to cover everything, but what I am going to be able to cover is a lot of the important basics to get you comfortable with the default UI. We'll also do a very, very brief lesson on C#, which, again, it's super brief. It's probably not gonna explain a whole lot for someone who hasn't done programming before, but nonetheless, it's something that's worth covering. So let's start a new project. I mentioned earlier that I'm using the Unity Hub, which allows you to install multiple different versions of Unity. So for more professional people, this is usually where I recommend. But getting started on it, we need to start by making a new project. And in doing so, to do so, you just have to look at the upper right-hand corner here and see that there is a new button. So you just click on the new. And it's going to give you a couple of different directives. I think even in the default installer, it will give you like a template saying giving you all these different options. We're going to stick with 3D for now. And then I want my project to stay inside the projects folder. And I'm going to call this Crash Course Unity. Feel free to give it your own project name. Crash Course Unity is just a quick default for the purpose of this. But before you hit Create Project, I'm going to hit Add Asset Package. And in here is the standard assets right here. If this is the only packet asset that you've if this is the only asset that you've downloaded for the editor, this should be the only thing that appears. I obviously downloaded a lot, so that's why you see a whole lot of wacky stuff on my list here, but you're just looking for standard assets in this case. Say done, and it'll give you, hey, you're planning on importing 1 asset. I'll give it a quick second or two so that other people can follow along. And then finally, when you're done with that, simply hit Create Project and let Unity do its thing. Let me know if I'm going too far ahead on the chat. There we go. Yeah, it's going to take a little while. In the meantime, a couple of things I should probably bring up real quick. As it is importing this, you can actually keep track of what the heck is going on. So here is the d/projects folder that I was creating my project inside. And it created a new folder called Crash Course Unity. That folder didn't exist before. If you go into it, you'll notice that it created a couple of different folders, including the assets, libraries, packages, project settings, and temp. I just was curious what that was. Obviously, while Unity is open, you don't want to touch any of these folders real quick, but one thing I do want to go over is really quickly about backing up your Unity project. If you do plan on backing up your Unity project, just to let you know, the library and the library and the temp folder are actually disposable. There's a specific process that you need to do to make the library folder specifically easily disposable, but under the projects, packages, and assets, these are really the only 3 folders that you need to keep track of. Especially if you're using like version control, these are the most important folders, in other words. See if, there it is, we got Unity, and I'm gonna switch back to factory reset right here. There we go. And extraordinarily, build target doesn't exist. Oh, okay. Well, these are not very important. All right, cool. So, just to make sure, this is what my Unity window looks like. I just want to make sure that everyone else has followed through. Please ping in the chat if we have not followed through and you need a little more time to wait up. Huh?
No, I mentioned in the chat that people should tell us if they need you to slow down.
Sure.
Nobody has said anything. So far so good. This is and
yeah, Amanda Levin should also be on there as well. Anyways, as this slide implies, the first thing we need to do is make sure we need to actually access. So this is the projects folder, the Crash Course Unity folder. We need to also access the assets folder. Inside the assets folder are the sample scene, standard assets folders. And here I have on a separate window right here, the Crash Course Unity assets. It has a fairly minimal number of files, but anyways, we want to copy all this into the assets folder, so do that. If chances are very high you don't have these meta files in your Unity folder. If that's, if it's not there, don't panic. I just have a specific setting to make those appear. I personally would recommend, if you plan on doing a backup process, that you do expose these files, and I can probably talk about that towards the end of the lesson on what they do and why you want to back these files up. But for the time being, you can disregard these. And then once you're done with that, just switch to Unity and let Unity do its little thingy. So we're not going to need this anymore. Real quick, while that is happening, first off, some art licenses. These are all Creative Commons licensed items, and I'm just mentioning it here because I don't think I bothered to modify these too much, but nonetheless, here are the licenses. The level.fbx is a modified version of mp-full.blend file from CTDA bomb, released under... All right, perfect. So, if you do you have Unity already open? If you do, you can just and you know, for whatever reason the standard assets process did not work, you can go to Window, General, Asset Store. By the way, this is post you created project and you're like, oh, I forgot to import the standard asset stuff. Alternatively, if you're saying that Unity crashed or something to that effect, you can boot up Unity again, go through the normal create a new project process, and simply not import the asset project, and then go through these following steps. But anyways, Windows General Asset Store, which apparently opens here for some reason.
Alright. It says, okay, let me create a project and see. Also, I missed a question from Omiya, but she seems to have sorted it out.
Search for standard assets. For me, it's the first thing that came up. And then hit import. Well, it'll say download first, and then you'll have to hit that button again once it's done downloading, and that'll bring up import. And this should be the window that you'll get. And then after that, you just hit the import button, and that's it. It does exactly, this basically does the same exact process as the new project with the standard assets checkbox checked off. It's exactly the same procedure. I don't know why it wants to re-import some of these. That's a little curious. I know that'll take quite a long while, so I'll give it a few more minutes to make sure they can catch up. In the meantime, here are the rest of the license. The grass.png file is from Sam Uncle, and finally the Rocket JPEG is from Marion Gagnon. And again, here is the Creative Commons license. All right, so I'm gonna keep going. What is Unity? Unity is a what you see is what you get. Yep, that's what this crazy acronym stands for. 3D and 2D game engine. It has many built-in features, including a physics engine, a sound, scripting, gamepad support, sort of, plugins, and more. Huh?
Who was asking about creative commons, so describe it briefly.
It's a copyleft. It's a copyleft copyright system. Wow, that is redundant. But long story short, it's a license that allows sharing your assets with the promise that you'll be attributed, unless you specifically choose one where attribution is not required. And then, of course, Unity builds to many different platforms, as most people would probably be aware at this point, looking through the Steam library. It's PC, Mac, Linux, WebGL, iOS, Android, Facebook Game Room, which is a weird one, Windows 10, PS4, Xbox One, Switch, etc. So all the major players here. Licenses. What we're using right now is the free license. It almost has every single capability there is. Like literally, there's almost no feature you're missing out on, regardless of whether you chose, pro license or not. It uses primarily C# scripting support. There are ways around that, but it requires creating plugins, and probably not a whole lot of people want to do that. And it's totally okay to sell your game. There are no royalty fees for the game engine. However, there is one exception, which is that if your company's gross revenue exceeds $100,000, or if your company is involved in gambling, or if your company is creating some sort of like educational game or something similar, where your budget is directly coming from the federal or state budget, then those do count as exceptions, and it is required for you to then start paying the licenses. I'm not going to go too far into detail about the licenses, but you can see them at the website at store.unity.com. There is the Plus and a Pro version. I believe if it's the $100,000 excess point, then you're required to get the Pro version. But the Plus version is more for indies, where they only need a subset of web-related services. Really, the licenses are for Unity, basically Unity-related web services, whether it includes the Unity Cloud, where it tracks your online repository and automatically creates new builds of your game. Like, there's a service for that. There's a service for if you want to create a multiplayer game and you're too lazy to create a server yourself, there's a service for that. So that's what these pro licenses basically are for. There's also for team collaboration as well, if you want to create a game between each other, and again, you don't know about repository, version control and repository too much, or are not interested in creating your own, again, there's a service for that. So now we're at that point. Let's start making a game. One thing that should be pretty obvious, as you have probably noticed, is that at the very bottom of the screen here, a bunch of icons started popping up. Drag, rigid body, grass, hit, level, and rock. And if you're asking yourself, where the heck did those come from? Well, it's simple. It's right here. You simply drag and dropped it inside the assets folder. So anything that basically displays at the bottom right here, the project pane is what I call it, it basically displays all the content inside here except the meta files, which I'll go over probably towards the end of the slides. So yeah, let's get started real quick. It's very simple. All we have to do is drag our model, which is the level.fbx, and just drop it into the scene. So let's do that right now. Ta-da! Oh, whoops, it disappeared. There. All right, cool, did it. We did it! And that's all you need to do. You're done. Good job making a game. I'm kidding, of course. But yeah, no, this is one of the first things you just need to do to get started on basically making a game itself. This screenshot is lying. You should be going to File, then Save Scene As, not Save Scene. And we are going to call this, I'm going to call this Crash Course. Feel free to give it a different name. There we go. And so that creates a new file right here, Crash Course, which creates a new scene file. All right, so if you got in that far, which it shouldn't take too long to get there, quick lexicon review. I'm going to be using a lot of these terminologies first without bothering to explain them, and then explain them post because it's Crash Course. So here it is. Let me describe a couple of things here. Assets. Assets is an industry-wide term for any files used in the game. For Unity, that's anything inside the assets folder. No dot. Models. Models is an industry-wide term for 3D sculpture files. They can contain animations and usually made in specialized programs such as Maya, Blender, etc. It is technically possible. There are tools out there to create 3D models within Unity itself. It is generally not recommended because Unity is more interested in being a game engine, a game making tool, than it is about making 3D models in it. So I will not rely on it for model development. It is actually pretty good for creating, like, there are some tools out there to create a prototype for a level, which can later be imported into an actual 3D modeling software to make it much more prettier. But yeah, outside of those like incredibly quick prototyping reasons, it's not usually recommended. The scene pane, which of course is the very top pane right here, basically just gives a 3D view of where all the things are positioned, in this case our level model, and lets you know how they're scaled, so on and so forth. In short, it's a 3D preview of what's going to appear in the game. In regards to models, what kind of model files can Unity import? It can import FBX, Collada, 3D Studio, Wavefront, and draw interchange files natively. You don't need to install any program to do this, it just figures it out automatically. Incidentally, I believe if you are exporting via Blender, there's two different options, text-based and just normal binary. Unity expects a binary FBX, it doesn't expect a text-based FBX, so just to let you know, don't export text-based FBX files, which is the most popular format. Everything? Oh, it just finished importing. So do you have an import dialog that shows up like this? Well, by like this, give me a couple minutes. There's gonna be a delay on this. I want to make sure that everyone is up to speed here. Huh?
She says, no, it's still recording. Oh.
Oh, okay.
Yeah. He's gonna consider everything.
But yeah, just import everything outright. Oh dear. Yeah, no, there's a lot in there. And actually, I'm gonna confess that the majority of it we don't need at all. Let's see if there's any other things that I need to go over. We will be posting a video on this on YouTube soon, so you're not going to be all that far behind. But anyways, if you happen to have the following 3D software installed, Unity has a way of wiring to them so that it can import models natively for that. So if you happen to have Blender installed on your computer, then it will import blend files just fine. Maya files, it'll import Maya files just fine. 3ds Studio Max, Modo, Cinema 4D, Cheetah 3D, and Lightwave. I do not recommend exporting files via these native formats. The reasons why is, for example, if you do plan on using the Unity Cloud service to create builds, it has no idea how to import, their servers have no idea how to import Blender files or Maya files, so it just flat out won't. When that creates a lot of problems.
Okay, the assets that finally have the former, where would she find the model that they're upgrading?
Yes, because she has not done that process yet. So don't forget to go back to your zip file and copy and paste all these items into the assets folder. I'll wait a couple of minutes because I know Twitch delay isn't the most amazing things, the most amazing human invention. It looks like she should be caught up soon because she just heard that.
Yeah. Wait, now copy what?
Huh?
She said, wait, now copy what?
Copy the content inside Crash Course Unity 2018 assets into it should have when you create your new project, it should have created a new folder in it. And then there's an assets folder in there. So just copy it in there. You can also, I think if you're using a Mac, then you can just drag and drop it because the way Macs work is you double click on a zip file, it creates a new folder with that zip name, and then you just drag and drop those files into the assets folder. I have no idea though. By the way, I love that all these file types are coming up in English except for CS, which is C# files. I don't understand why.
What time is our session go till today?
Hopefully I'm gonna finish before 9 o'clock. How's our situation going? And then remember, once you do that, switch back to Unity. And then there's a level file right here. You just drag and drop that from the bottom to the top. By the way, that is exactly where we're at. Sweet. Awesome. Okay, thank you very much for everyone's patience here. All right, navigating the scene pane. This is fun. So, as you would expect, Unity is a 3D game engine, which means it needs to figure out how to navigate 3D with just two or three mouse buttons. So here are the controls. I would recommend actually playing around with them. I'm using primarily a 3-button control, so this is the one that I use the most often. For those who didn't know, most 3-button mouse controls has a scroll wheel instead, but you can actually push down on that scroll wheel to count as a 3rd mouse button. So when I switch to this and I'm in the scene right here, the left click will allow me to select any of these items, of which there are 3 in this scene right now. This level, this camera, and this sun. If I just push down on the scroll wheel, that will allow me to pan. And finally, the right mouse button allows me to look around from where the viewport is looking at. And then scroll wheel up and down allows me to zoom in and out. You can also hold down the shift button to make this a little faster. So this is not no shift, this is with shift. What if you don't have a mouse? Left click is to select. Double tap does not do anything. Scrolling up and down seems to work at the very least. The fact that you can't turn around the camera is... I don't know. Wow, I didn't research that, I'm sorry. This is new. We didn't do this in the last course. There are a couple of interesting controls at the upper right-hand corner, which is, there's this little thingy right here. This little weird thingy, and you might be asking, what the heck is this? And as it turns out, it allows you to it allows you to change the perspective of which direction the camera is facing. So if I click on the X here, you might notice that now I'm facing in this direction. If I click on the Z, I'm looking in this direction. You can kind of do this perfect angled views. But wait, there's more. If you click on this little, it says persp button, it'll switch to orthogonal, which basically makes the whole game look like Civilization. And then if you click on ISO, it'll toggle back to perspective camera viewport. You can do the same thing by clicking on this little middle cube there, and that'll also create the same effect. Likewise, these controls still remains the same as before. Finally, there's a really faded out lock at the upper right hand corner that basically prevents rotation from happening. And then you can click that again to toggle it back to unlocked. Finally, the game objects. This is going to be fun. All right, so on the upper left-hand corner, there's a couple of different controls right here: the hand tool, move tool, rotate tool, scale tool, rec tool, and then move, rotate, or scale select objects. Wow, that's a mess. Hand tool is the most obvious one. Basically, it's panning. So if for whatever reason you don't like using the middle mouse button for panning, you can just click on this tool and do panning here. There are a couple of other reasons why you might want to select this tool, but for the time being, that's just imagine that that's what the purpose for that is. The transform tool, move tool right here, allows you to move an object on an axis. You just have to click on the arrow itself, and it allows you to move it, the object in that specific direction. You can also click on these little boxes to restrict the movement of the of transforming these objects to a specific plane. So like for example, this is, the island is not going up and down from the view here, but it is going farther away or closer to the camera. If you use the rotate tool, similar to the last action, you can just click on these little colored axes to rotate on that specific axis. I'm also using Control-Z to undo my work. Whatever is the OS equivalent of that, for example, Command-Z should do the same thing. There is also this weird white outline that allows you to rotate from the rotational perspective of the camera. And then there's this little dark sphere here, where if you click on it, it allows you to do some really, really bad freeform rotation. Finally, the scale tool. Well, not finally, there's still more. Basically, clicking and holding, dragging these axes allows you to scale based off of that axis. But there's also this uniform scale. If you click on the cube, you will scale the object on a uniform, basically the XYZ with the same value. Most of the time, this is what you're going to be dealing with, rather than scaling based off of axis. Rect tool. This doesn't really do anything. Okay, I'm wrong. It does actually do something. It is actually meant for 2D game development. Don't use it for 3D game development. It does very unexpected things. And you know what? I'm just going to call this the super tool. So, the super tool. Remember how I went through all these little axes and said you can just click on the axis to move this, or you can click on the little square to scale this? Well, it's all that tool into one. Wow. So, admittedly, you don't even have to click these anymore. You just have to click on this and be a happy camper. Now you know. This would be the axis for the rotation. That would make sense. But yep, there's a super tool. Oh, right. There are these two buttons right here where if you just click on it a couple of times, it'll toggle between different values. Each of these are meant to stand for the first one. This is where the tool will be centered in. It thinks this is the center, so that's why when I click on center, it's pulling it there. And then pivot is, it thinks this is where the pivot point is. Pivot point is actually defined on the 3D file itself. So if you have a 3D artist, you can let them know that the pivot point is in the wrong position. But yeah, that's what that is in regards to. Local, of course, is rotating things based off of local coordinates, and then global is transforming or rotating things under global coordinates. You can tell because the orientation of the super tool has switched to a different direction. And finally, the middle tool right here. There is the play, pause, and step button. Basically, if you click on play, it'll play the game, of which absolutely nothing will happen. And then if you want to stop the game from playing, you just click on the play button again. If you click the play button and then hit pause, it'll pause the game. You can see it paused right here. And you get to basically adjust things a little bit and see what happens. The step tool is basically pause, except moving forward one frame. Hierarchy pane. This is the pane right here on the left side. You might notice that if you click on each of these items, it will immediately select that item in the scene itself. So for example, if I, here's a camera icon right here. If I select it on the scene, it highlights the main camera under the hierarchy. If I click on the directional light, it now highlighted the directional light right here in the project itself. So there you go. Basically, the hierarchy and the scene pane both correspond to exactly the same thing. The hierarchy pane pretty much exposes any items that are invisible by itself, but still has a position somewhere in the scene. You'll see it here. So in short, basically anything inside the hierarchy is everything that you see inside the scene itself. Scene then is just a 3D graphical representation of what the hierarchy contains. You can also change the order of how each item appears in the hierarchy pane. And you can also create a trees of objects, so groups of objects, which I'll be talking about later. Lexicons. These are actually Unity terms that we're going to talk about. We do not use these in the wider industry, but game objects is a Unity term for any individual objects. These are game objects. If there is a line in the hierarchy, that is a game object, flat out. They can be activated or inactivated. I'll go over that later. And every entry in the hierarchy pane is a game object. Scene is Unity's term for files storing a collection of game objects. They store a reference to the assets in the assets folder and has a .unity file extension. So this right here, the new Unity file that we've created, by the way, for those catching up, to create a new scene file, you just have to say save scene as, and then give it a name. But yeah, the fact that there is a scene file right here, and if the assets folder recognize that it's right there, means that, you know, this is a scene file. It contains all the references to the assets as well as these game object information, their name, where it's positioned, what the rotation are, scale is, so on and so forth. Okay, let's move on. Lots of explaining to do. But this is where things get a little fun. We're going to start off by creating materials. What is materials? This is Crash Course. I'm not going to explain it to you until we created it. So, hey, we're going to start by creating an actual material from the project pane. This is really simple. There's a little project, there's a little create menu bar right here. You click on that, and holy nuts, there's so many things. But there is material right here. You just click on material, and it creates a new file right here. I'm going to call this grass. Yeah. And then when you do that, you might notice something. The right side of the screen, which is called the inspector right here, has changed ever so slightly. You wonder why, because maybe grass is highlighted? Anyways, one thing you want to do real quick then is to kind of give this, to make this preview right here, which just is not very descriptive, make it look like grass. So here it is, it's very simple. Notice that there is a little square next to the albedo field. We'll just drag and drop the grass right there. And here it is, we finally got a grassy looking thingy. And then from there, we have this level scene right here. We'll drag and drop the new grass material into where it's green. Ta-da! We got grass. You can tell by just enhancing the, just CSI enhancing. And see, yes, this is definitely muddy grass texture. Now, you might notice that it's really, really shiny. That's because there's this smoothness value, which is currently set to 0.5. You can just decrease that to 0, and it will look a little more mundane. I would also recommend changing the color under right next to the albedo. This is the tint field, and you can adjust the tint to make the grass look even greener. You can also make it look redder. You know what? I'm going to be goofy and make it red. Do not follow what I'm doing here. Feel free to make your grass actually greener. That's what it's meant to be. And that's pretty much it. We just need to do the same thing for rock, actually. By the way, yeah, grass. One other method on creating materials is this context menu right here is actually exactly the same context menu as create. You just have to right click on the assets, the projects, empty space, and it will give you a bunch of options. And if you go under create, then it gives you material. So you can create a new material that way. And I'm going to call it rock. Drag the rock albedo file right here, and then we're going to drag and drop that material to the walls. So now we have a really shiny wall. And I am going to be weird and make this hypermetallic and super smooth. Look at that. Looks just like metal. If you couldn't tell, by the way, as you would expect, metallic is the metallic is the reflective value, while smooth is the how much light it reflects value. So if, for example, you want to create plastic is not very good at reflecting things. So you'll bring the metallic down to its minimum, but you'll bump up its smoothness to a rather high value. If you want a metal that is really rough, kind of like some of those rough stainless steel-ish textures where it reflects color, but that's about it. You'll probably go really high on the metallic, but smoothness to 0. And then, if you want some sort of stainless steel, like silverware, where it's actually reflective of something, you'll give it a nice smoothness and a metallic value. And of course, if you want flat out grass or dirt, you'll make the metallic and the smoothness values to absolute 0, because they're not very good at reflecting anything. They're not very smooth either. So yeah, have fun with that. Feel free to adjust the tint again. I'll make this green. There we go. I'll make the
Where was this level created? What was that created in that program?
it was created in Blender.
Did you create it, or was it a Creative Commons?
It was a Creative Commons asset. So I do not know how they made it. I'm just using it because it looks nice. The rock is greener though. Oh, I should have quickly mentioned this. If you hold the right mouse button and then use the WASD control, it allows you to do a first-person flight simulator game. This is based off of, I think, more like Unreal and Source and the like. But if this is more your jam on how to adjust your view, this is a pretty good option as well. I lost control of where the camera is. Oh, speaking of camera as well, another fun shortcut. If you select an item and you want to be able to see it in its entirety, make sure your mouse is inside the scene, and then tap F. There we go, we can see everything. If I want to see the camera, I'm going to tap F again, and it'll zoom into the camera. Or the directional light. So that's a really useful tool.
Wait, F doesn't bring me back to the camera.
Click on the camera, and then make sure your mouse is on the scene, and then tap F. Did that work?
Yeah.
Sweet. Alright, so now I'll explain what the heck materials are. Material, yes, is an industry-wide term. It is very commonly used. Material is supposed to provide a value of what the surface looks like. So, for example, as demonstrated with the metallic and the smoothness value, it will create like a metal-like surface, or plastic, or shiny, similar surfaces. In Unity, these are stored as a .mat file, and they're shared between different game objects. Changing a material's properties will update all game objects with the same material. In this case, level happens to store 2 different material slots, which is totally possible. If we're creating more objects into the game, and you drag and drop these materials in there, they'll basically be sharing that information. Models retain information on how the models are mapped to the surface. So if you're wondering, hey, how did it figure out that it needs to map, the grass in this specific way? That is the model telling the game engine, these are the coordinates on how to map that kind of thing. So unfortunately, it's up to the artist to figure that out. Normally, you would have to create 2 materials by hand, which is still true. This line was made back when Unity did not bundle the material as part of the model. But this line is no longer true, so sorry, I forgot to update that. The renderer component, ooh, there's a new word right there. The renderer component holds the material file. I'll talk about what that means later. The inspector. The inspector displays the properties of the object that you have selected. This can actually be the assets inside your assets folder, or as it may be, any of the game objects inside the hierarchy. So you might notice, for example, when you click on level, it has the level mesh filter and a mesh renderer. And hey, there's this materials group right here, and it says that it has the grass, it contains the grass and the rock material. Which means, based off of my previous terminology, this whole mesh renderer here is a component. Basically, one can edit the properties inside the inspector field. This can be done by, for example, I say, hey, I don't want you to be receiving any shadows, so there's a little shadow right there. If I uncheck that, it all disappears. We obviously want shadows, so I'm going to keep that there for now. Images, since we just talked about textures earlier, these are the image files that we can import. There are PSD, PNG, JPEGs, XIF, BMPs, Targa files, and more. Yeah, these are natively supported. You just drop them in, it'll import it, Unity will import it just fine. Textures. Textures is another industry-wide term. It's basically images that are meant to be skinned on a model. The models themselves contains coordinates that indicates how the texture is supposed to be mapped on the model itself. We call this UV mapping. It's called UV because they said we need the XYZ coordinates to indicate where the vertices are. And then why not use the next 3 letters, UVW, to map where the texture is? And then they forgot W. Components is Unity's term for containers with specialized information. A game object itself can have a list of components. As you can see here, this level component, or this level game object has 2 components, actually 3, excuse me. The transform, the level, and the mesh renderer. These are just previews and do not count. They can be enabled or disabled, and every entry in the inspector pane is a component. So, right, let's add in a camera. We are just flat out going to destroy this main camera that we had earlier right here. You know what? We're just gonna hit the delete button. There, gone. The delete button, by the way, is usually in the upper right-hand corner of your keyboard if you're having a little trouble finding it. I don't think backspace works. Then, from there, you can search inside this little search bar under our projects. We're gonna look for FPS controller. And here it is, right here, FPS controller. Yeah, FPS controller prefab. We can just drop that into the scene. And then it places it really high up on the ground, so we just need to make sure that we position this camera so that it is close to the ground as possible. Okay, that's through the ground. There. By the way, I didn't really talk about this. There's a little game tab right here next to the scene. If you click on that, this is what basically the view is going to look like. So the game panel right here gives you a preview of what you'll see. Give that a few minutes. I happen to have a Mac, so command backspace is my command. Although in this it says delete. It should be command delete. Oh well. Alright, let's play the game. So I'm using a super tool right here, but you can either choose the move tool or the super tool. And anytime there are these triangular axes, you just move them around. You just click and drag them around to move them to a specific axis. So you should be seeing this. Those of you that attended my crash course lessons will be very familiar with this phenomenon. It's called Oh Snap, What Did I Forget? So, oh snap, what did we forget? The answer, we forgot a collider. Ooh, what is a collider? Well, it's what keeps you on the ground, that's for sure. Simply select your level. I'm just going to click on level right here. And there is an add component button at the very bottom. We click on that, and I don't know why it's bothered. It's thought I wanted to search something. This is what the window should be looking like. From there, you just select physics, and then select mesh collider. And then we play the game again. There we go. So controlling the FPS is very simple. You use the WASD to move around, space to jump. I think it's shift to run, and that's about it. Yay! So have a little fun and explore your majesty. Oh, it's mouse. Yes, I forgot about that. Sorry, but okay, so at this point, I am actually legitimately going to say, congratulations, you got your pretty much your first game. But we're going to do a little more than that. So I'm going to continue as other people are playing.
Yeah, sorry, that's questions. How does this sound effect get credited or need to be?
I think the sound effect comes with Unity. It's whatever Unity's license is. Unfortunately, I didn't look it up.
Is one playing by default, or did they add one? Because I didn't hear what my volume sounds.
Also, I was asking, wait, sorry, how to add the library? Can't watch video and read video at the same time, sorry.
Yep, no problem. And let me take care of that real quick. Let me set up. Simply, so select, let me unselect something. There we go. So in the scene, you can select level, or in the hierarchy, select level. It doesn't matter which because they're one and the same. Under the inspector, scroll to the bottom, click on add component. It will give you a list of all the categories of components that you can drop in. We're going to want physics. And then search for mesh collider. I also recommend just searching mesh collider as well, but physics, then mesh collider, just click on that and you're done. It's very simple. I'll be surprised if she hasn't, when the stream reaches to that point, if she can't catch up, so I'm just going to keep moving on. Lexicons. So you might notice that the FPS controller we dragged in is called a .prefab. Prefab is basically a prefabricated object, as you would expect from architecture and whatnot. It's a Unity-specific term. Files with .prefab file extensions are basically prefabs. They appear in this weird cube icon for whatever reason. Most of the time, it'll actually give you some sort of preview. It allows you to copy a group of game objects from one scene to another. We'll be creating prefabs ourselves in the near future. Thank you. Colliders. This is an industry-wide term. Colliders is an industry-wide term for shapes representing the boundaries of an object. It's used by the physics engine itself to determine how objects should be interacting with each other. Very simple. As you would expect what colliders would do. There are a lot of different colliders. Mesh collider is the type of collider that attempts to mimic the shape of a model surface. They are wow expensive and not very efficient. So generally speaking, it's not recommended for anything but objects that never move. Box colliders are basically rectangle-shaped colliders. We'll be talking about that shortly. Sphere colliders are colliders that looks like spheres. You can change the radius and so forth, but you can't make ovals out of them, regardless of how you scale them. And finally, capsule colliders are colliders that looks like a capsule. Basically, they're like a sphere on the top and not cone, a cylinder in the middle. So kind of like a pill shape. The thing about capsule colliders is it's most often used for human characters because they tend to be very tall. And so it's the closest thing that you can get them to describe them. That said, I want to be clear that it is technically possible to combine colliders, as we're about to demonstrate in a short minute. All right, let's add some interactive stuff. Let's add in this cube right here. So here's where our FPS controller is. I'm clicking on the FPS controller right here, and it's looking directly in this direction. So I'm going to say go to game object, and I'm going to create a new 3D object and cube. It right now created right on top of the FPS controller in my situation. It'll probably create it someplace else. I'm gonna drop it right in front of the camera. And so when I play this, if you're paying attention, you'll probably expected that absolutely nothing would happen outside of the fact that there is a cube right here and that you can stand on top of it. But that is okay. Because, oh, by the way, so as mentioned earlier, the cube has a box collider, so that's why you can collide into it. It just automatically creates that as you create a new cube. But there's a very special formula, there's a very special ingredient that you can add in by simply clicking on Add Component, and then going to Physics, and then finally adding what's called a rigid body, and hitting play. Well, our cube fell down. That's a start. And your character can't push it around for whatever reason, but by jumping around it, you can cause it to kind of twist and turn.
Alright, Moa says that was a little fast, I couldn't follow. How can I get the 3D object? She wants to know how to get the 3D object.
Game object, 3D object, cube.
It was a little fast.
That's fair. There's also create, 3D object, and cube. Those are the two other methods you can do that. Or three, now that I remember, this is also possible. Right click on hierarchy, 3D object, then cube. Whatever is the most convenient. Any questions so far? Okay, moving on, using a script. In the project pane, select drag rigidbody.cs, and drag it under the FPS controller. Got it. So that's the method I chose. Here is the drag rigid body script. It says C#, so you know you got the right one. You just have to drag and drop it into the FPS controller under the hierarchy. And when you do so, when you click on the FPS controller, under the inspector, it has this first-person controller, the character rigid body, and audio source, but it should also now have a drag rigid body script attached to it. So now, when you click on that, and you see that cube, and you click and hold the left mouse button, you drag the cube towards you. And then you can let go, and that allows you to toss the cube like it's nothing. You can technically do this anywhere on the map, so like you don't even have to be looking at the cube. Oh, maybe it doesn't work. Maybe I do have to see the cube. So have fun with that.
So this was an external script that was written that defined the behavior between your mouse button and the interaction with the cube. Is that it? Would be a good description of it?
This is, yes, an external script that you just attach to your FPS controller, and it keeps track of whether you clicked your mouse or not, so that you can drag the cube around. Yes, question.
Who's cube can't move?
Huh?
Her cube it can't move. So it's something that's legit move.
Sorry about that. Is the component drag rigid body on the first-person controller? Simply click on FPS controller under the hierarchy right here, and then see if it's on the inspector. If it is not, and the drag rigid body script is on a different component, it could potentially be on first-person character by accident. You can just right-click on it and say remove.
Yes, but the cube is mobile.
Huh?
Yes, but the cube is mobile.
The cube is mobile?
Is immobile. It's not
Oh.
like-
Go to your cube. So let me reset that. So in this case, as in like, right now you can't move the cube at all, right? So just click on Add Component on your cube once you selected your cube in the scene itself. Whoops, like I do right now. And Add Component, Physics, and click on Rigid Body. Let me really quickly attach that before I forget. All right, we actually are very close to the home stretch. Thank you very much. Give that a few more minutes. Alrighty. So I mentioned earlier that you can combine colliders together. This involves using a system called forward kinematics. The way to do so is we're going to add a sphere onto our cube right here. First off, I'm going to make sure that nothing is selected. Yep.
How do you grab it?
Left click. Left and hold the left mouse button. Make sure you're looking at the cube itself. So here we have the cube. Well, it sounds like she wants to get that done first. Huh? Oh, I see. So we'll right click and say create a new 3D object. in this case, we're going to create a sphere. Feel free to actually create any shape in this case. Capsule and cylinder are actually exactly the same thing, but regardless, I'm going to go with sphere. So here, I don't know where I created that sphere, but I'm going to drag that sphere so that it places it at the corner of the cube itself. I should have just panned. There. It's gonna make me as happy as possible. Move that a little bit up. Sweet. So basically, we have this silly sphere right here. But what we can do is we can drag that new shape into the cube under the hierarchy. So I should probably zoom in for this. So here it is, drag, and you can see that it highlights the cube. If I do that, it makes the sphere a child of a cube, if you know how the tree structure terminology goes. Now, if you do that, and you play the game, and toss your object around, your cube and your sphere will fall along with each other. And not only that, if you were to like scale or rotate these, basically the sphere will fall along with where the cube is anywhere. So that's actually part of what's called the forward kinematics. I'll go over that detail right now. First off, I added in what's called a rigid body, which is an industry-wide term for any interactive physics object. It basically contains information when you click on the object and then look at the inspector. It has stuff like, for example, mass, drag, and center of gravity. It turns a group of colliders, including those in the tree as children, into a single interactable shape. Child is an industry-wide term for an object whose position, scale, and rotation follows that of another object, the parent. So that's actually parent and child is the two new terms I'm bringing up. In Unity, they appear as nested entries in the hierarchy tree view. This follow parent calculation process is known as forward kinematics, a term in 3D animations. Most people will probably not recognize the term forward kinematics, so that's not exactly an industry-wide term, but making things into a child, for example, is fairly common, either that or pinning. We can actually change some physics properties on each of those items by simply changing the physics material. We're going to create a new physics material under the project right here. I'm going to click on Create, and then I'm going to click on Physics Material. And this created a new physics material file. Notice there's physics material and physics material 2D. Don't mistake the two. We need physics material, the normal one. And we're going to call this Bouncy. And then because it's bouncy, right now the bounciness value is set to 0. I'm going to say 1. It takes a value from 0 to 1, by the way. So yeah, here it is, 0 to 1. So it doesn't matter if you type in 100. It's going to bring it back down to 1. And I'm going to drop this on the sphere, actually. The sphere itself has a material. When you click on the sphere and then you check out the sphere collider, it has what's called a material field right here. We're just going to drag and drop the bouncy material onto that sphere, and you can play the game and see what happens. So it's a little hard to tell, but if you drop the object on the sphere end, so that one, it dropped on the cube end. Oh, I guess I'm just never going to be lucky on this. But yeah, the sphere end becomes a lot more bouncier than the cube end. Wow, I'm a terrible juggler. There we go. That looks a lot better. So there are ways to adjust the physics properties of an object. Oh, I dropped it on the cube end in this case. So while you're playing around with that, you can listen to my sweet voice as I explain what physics materials are. Physics materials is an industry-wide term for how objects are supposed to interact with the collider. It basically adjusts how slippery or bouncy an object is, and/or actually. In Unity, materials are files stored as .physics material shared between game objects. Changing a physics material's properties will update all the game objects with the same physics material. Very simple stuff. How is everyone catching up so far? Cool, cool. Finally, let's start adding some sounds into this, and we get to talk a little bit about scripting as well. So, yeah. When you click on the cube, these are all the components expanded. We're gonna go click on the cube, and then under our inspector, scroll all the way to the bottom and say Add Component. This time we're going to click on Audio, and we're going to add in Audio Source. I actually have no idea what any of these do. What are these? Wait, there's a spatializer? Whoa! Anyways, I'm getting distracted. Audio source. Yeah, we do. And then when we expand our audio source, it just looks like this. With that, we have an audio file right here. You can preview it. So going back to the cube, we can simply drag and drop that audio clip into the audio clip field. Again, hit, drag into audio clip. So if you play the game, all right, we were not very close to that cube. I'm gonna move that cube closer to our player here. There we go. You can barely hear it. The spatial blend is set to 2D. Is it just not very loud in the first place? That's very strange. So what should be happening is that you should hear the sound effect play immediately. Now, I did adjust one value on purpose. This is the spatial blend. I think towards the end of the slides, I say that you should set this to 1. But we're going to do that right now real quick. Just for the sake of it. I'm a little confuzzled as to why it is so quiet here.
Change the output as the master. Change the output as the master.
Good question. It requires creating another file, however, which is called an audio mixer, and that allows you to pull it under specific audio mixer groups. So, for example, if you want to categorize things as specific types of sound effects, it's possible to do so. That is a little beyond this tutorial, so I'm not going to go over it. It is, however, if you, to plug in our Patreon, we do have any sort of materials taught in the 3D Orbit group. is all in there. So, and one of the materials that we go over is the audio mixer, which is what's involved in setting up this output field for an audio clip.
So this audio is supposed to trigger when it hits the ground? Is that it?
No, it's supposed to trigger immediately as soon as you play the game.
Oh, it does that.
If you can't hear it, like I can't hear it, so I'm a little confuzzled as to why, but that's what it's supposed to do. We're gonna create a new script after this. Oh, sorry for your ears right there. Under the same cube where we created the audio source, you just have to click Add Component, and then you can drag to the very bottom, and it says New Script. Hey, cool. And we're gonna call this new script, yeah, I think we just call Play Sound on Collision. Yep, that's exactly what we want.
Another question slash issue. Amanda says can't get the cube sphere to be attached to each other or move when I try to grab.
Hold on for a second, and then I'm going to click on Create and Add, and that creates a new script. Since the script has absolutely nothing, I'll go over Amanda's problem real quick. So what I assume is happening is that she has the cube. Let me zoom in. Whee! So she probably has the cube and the sphere separated from each other. What you need to do is whatever is going to be the child, you're going to need to drag that, in this case the sphere, and drag it into the cube. It'll cause the cube entry to highlight like this in the capsule format, and you let go, and that creates the sphere inside the cube. The reason why putting the sphere inside a cube is important is because the cube is the one that has the rigid body. The parent of all these colliders should have the rigid body component. See if that works. Make sure also the sphere does not have a rigid body component. A lot of terrible things happen if there's a rigid body in a child of a rigid body. Although there is a pragmatic reason as to why you might want to do that. That's another day for another time, has to do with scripting. Anyways, if you have successfully created a new script, you can just double click on it and that'll cause Visual Studio 2017 to open up on my computer. See under the cube that you created a new Play Sound on Collision script, you can double click on that and it'll cause the editor to open.
I'm still having issues. There's no lock. Drop sphere in the cube and make sure cube has rigid bodies. Cube doesn't. But can't get them moving.
Did she forget to add a rigid body component to the cube?
Said the cube has rigid body. The sphere doesn't.
Did she accidentally click is kinematic? On the rigid body?
Whoops, cube didn't have rigid body. Okay.
Well, to add a rigid body, remember you just have to go to Add Component, Physics, and then Rigid Body. Also, let her know to if she has. I guess we should wait until we can verify that she followed along up to the point of adding a new script to the cube.
Okay. She currently has lost it on her screen.
Oh, well, you can always, you know, unplay. It'll always come back. That's the whole point of a game. It always comes back. Are you up to a point where everyone can access the script? Hooey! This is the fun part. Copy the following. This. Which is not very useful, I know. You don't have to follow these brackets if you're... Oh no, I guess it is exactly like that on mine. You don't need to... I don't think you need to copy this line per se. But the new lines are audio source audio. Under the start function right here, notice there's a bracket and then a close bracket, and in between there is an audio equals get component audio source. We don't actually need the update function, so feel free to delete that, or just leave it in, doesn't matter which. I'll probably go over what I mean by function on later. But what we do need is void collision enter, and in between these parentheses collision info. So that's on collision enter, by the way. And this needs an audio stop and audio play. Yes, you can replace that.
I can replace that?
You can replace that with on collision enter, correct. Unfortunately, I'm not gonna, it's a little beyond the scope of this tutorial, but there is a reason why it gives you update by default. In this case, it's not important. So let me do that real quick. Yes. Please save the file, or else it's not going to do anything.
And when we save it, it automatically updates in Unity?
Yes, when you switch to Unity, it'll automatically update. Wow, okay. Visual Studio's being rude at me. So it should look something like this. Enhance. Then you can switch to Unity. If you have not done so already, I highly recommend switching from audio source spatial blend from 2D to 3D. You can play the game. So technically I should be hearing things, but I'm not. By the way, I highly recommend playing around with a spatial blend. See what happens when you move it to just 2D and play around with the game. Then jack it up to 3D only and play the game and see what happens. Pitch is another good one to play around with, and volume. Though volume is kind of obvious what it does. If you really don't like your ears, feel free to check the loop checkbox. It does exactly what you think it does. Otherwise, you can uncheck it. I actually do know what reverb zone mix does, but because we don't have any reverb zone in our game, it does absolutely nothing. Oh, and then let's uncheck Play on Awake. Play on Awake checkbox, basically what it says is play the sound effect as soon as the game starts. Which is useful if you have music, but Most sound effects, you don't want that. So let's see, this is going to be a rare case where I'm going to ask the viewers how far they've reached. Because it is something that's a bit time consuming. Yeah, let me switch back to the code itself because there's a lot to swallow.
Somebody got an error.
So error usually means there's like a little red squiggly line. If there's only a green squiggly line, you can completely disregard that. But this is what my code looks like. Spelling does matter. Capitalization also matters. This is coding. Capitalization matters heavily.
But spacing doesn't matter?
Huh?
The spacing matter?
Spacing does not matter.
That's perfect.
No, that's a good question. So while we're sitting around here, do you know why they call C#?
C++ was iterative from C.
Right. So the Frederica got it correctly, but the joke is C# is actually C+++++. That's a it's called a warning. You can disregard it.
Green text. That's just commenting.
Oh, this used for initialization? Or this little green squiggly? Because these green...
It's used for initialization, or update is called once per frame.
Yeah, it might help if I delete all the extraneous code that we don't need. Here. Did Amanda make it? How far are we? Oh, we have 14 slides left. I'll probably give it 2 more minutes because, yeah, as with everything programming, I expected this part to be pretty involved. Void, good question. A function, so you don't have to write this. A function actually expects, int will be a better, int as an integer, actually expects something that's supposed to be returned. So if I say int function, I guess, return 1. Oh, she hasn't figured out how to attach the new code to the sound yet?
Yeah.
Let me...
I don't know how you need
let me finish explaining this part. So the question was, what the heck does void does? Void indicates that nothing is going to be returned. Most of the time when you write a function, you indicate what you're returning, in this case int for this function, and then in turn you have to write down in the middle of the function return, let's say 1. However, if you say void, then you can essentially just say return, and it returns absolutely nothing, or you can get rid of it entirely at all, and it will still compile. So what does void stand for? Void stands for nothing. Yep. To recreate this situation, I'm going to close this. I'm going to remove this. Simply go to add component, scroll all the way to the bottom, and there's new script. When you click on new script, it'll ask for a name. Simply enter a name. I called it play sound on collision. Now it's saying, hey, you already have this. But I am assuming in Amanda's case, oh, I should have mentioned something. Make sure you select it on the cube first. I totally forgot to mention that. It needs to be on a rigid body in this case. But anyways, component.
It's already been including it, you can always add that. Script. You can add an existing script if you already created it.
Right. If the script has already been created but it's just not working, you can give it like a number too, and it'll just accept it. And then remember to hit create and add. I think Amanda has access to the slides, so I would recommend copying the code from the slides. Apologies, I do have to move forward at this point. So, the scripts, what do they do? If you're writing it up right now, just feel free to listen as I babble. I'm going to be babbling quite a long time to explain what the heck this code does. All right. Blah. So obviously, if you couldn't tell, play on sound collision right here is the name of our script. We need to define it as a public class. That is extended by a mono behavior for Unity to accept that that is a valid component to attach to a game object. I'm not going to go into detail as to why this syntax is necessary, just understand that that is. Because this is C#, anytime you put in an opening bracket, you're basically saying that you're defining this class in between these two curly brackets. So the first thing we're defining here is a member variable, audio source audio. And you might be asking, wait, what is that? Audio source is this, right here. Whoopee. But we're creating a variable of that. That means we need to we're telling the program to store this information. And by default, it will be set to null, which is what this code looks like, which is what this code will look like. But we're just getting rid of it because it's extraneous code. Second, there's a void start function. So Unity follows an event-based programming system where it just uses, you just have to define the function name itself, void start parenthesis, and then these parentheses. And then it will automatically run when the game starts, when you hit the play button, anything that is any lines that are in between these two curly brackets. As it turns out, equals get component audio source, which is to say it's going to search for what's on that game object and find an audio source and set that value onto our variable audio.
We have that variable audio
Yes, correct. So,
You have hundreds of audio assets that might name player footstep 1, player footstep 2, sword.
yes, correct. So the question was, we can rename this audio variable to anything we want, right? And the answer is yes. You can rename it to ho, 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 and bottle of soda, and it will accept it.
And you right-click and change every instance of that name, huh?
Oh, so there's a feature under Visual Studio. If you right-click and say rename, it'll automatically rename all of these instances. You can hit escape to cancel that. On collision enter. As the name on collision enter implies, it is a function that triggers when a rigid body collides with a collider. It will pass in the information on how things collided into under this collision info, but we don't need that information, so we're not using it whatsoever. In between these two curly brackets, we're saying audio component, please stop what you're playing, and then play it again. We're asking it to stop making the sound effect because that's the only way to reset it, to play it back from the beginning again. If you don't call stop and the audio, the sound source is already playing, it will just keep continuing that audio. So you need to tell it to stop so that it switches back to, oh, I need to stop and move the sound effect cursor back to the beginning. And then finally play actually makes the sound effect play. Unity can import any of these sound effects natively. It can import WAV files, AIF files, AIFF that is, MP3 files, and OGG files. WAV files and AIFF are both what's called lossless audio files, which means they have the utmost best quality you can ever imagine, sound quality you can ever imagine, but wow, do they take up a lot of space. They're usually best for short sound effects, so it's generally recommended only to use these for sound effects, so that you give them the best clarity. It also has MP3 and OGG support. OGG support is native, so it's best for any sort of PC and console situation, where if you're building it for Mac, for example, it'll just use the OGG file directly. MP3, while it does support it, it will automatically convert to OGG if you're exporting to PC. However, it's the exact opposite scenario when you're building for mobile devices, because it will natively use MP3 files for mobile devices. And if you're building from if you're using OGG files, it will actually convert the OGG files to MP3 for mobile devices. Why? It has to do with platform optimization. It's just weird like that. Duplicating the cube. So I mentioned earlier I'm going to talk about how to create prefabs. These are the directions for creating a prefabs. It's super simple. You see this little cube right here in the hierarchy pane? We just need to drag that into our projects pane right here. Bloop. And now you get a preview of what this cube looks like. And from there you can drag and drop this cube to anywhere in the scene. And they'll all have the same property as the original cube itself. Heck, you can even make some of them larger if you want to.
So that takes everything you've done to that cube, puts it in a little bundle as a prefab, and then you can pop that out of your assets anytime you need to.
Right. If you create a new scene, for example, it's really useful because you can copy those group of information, those group of game objects into that new scene as well.
So let's say you create a level and this prefab is the character with the sphere and cube. You know, on level 2, the character shows up again, you just take it out of your asset folder and put it in there.
Right. So to repeat that again, the reason why one might use this is, let's say you have 2 different levels. You started with the first level with a character, but you want to move that character to the second level as well. The easy way to do so is by making the character a prefab, and then when you start on making the second level after you're done with the first one, you can just drag and drop the prefab of that character into the second level, and you'll be done. Any questions so far? Now, if you're asking a question of why you cannot select, you're constantly dragging and dropping the, oh, I guess that worked. Huh, strange. Oh, I guess that cube is a view. So, my script is not the most well programmed, so you're probably not going to drag the cube that you want all the time. FYI. Yes, I did write the drag the cube script, and I did it poorly. That's on me. How is Amanda doing so far?
I think she's okay.
Okay.
I haven't heard any updates recently.
Yeah, I'm sorry that I had to move forward a little quickly for her, because the programming part is just one of those things that I figured would take a lot of time. We're almost done. See, there's only 10 more slides to go through. This one is a little fun. You have this grass texture right here. If you hit the, I think if you can right-click on this. No, interesting, it doesn't give you that option. Strange. Okay. When you select the grass, there is a shortcut, called Control D or duplicate. If you hit Control D while selecting this grass, you'll duplicate it. Ta-da! So now you have 2 files, grass1 and grass1. Now we're gonna do a little thing silly here with grass1. Right now under the inspector it says texture type default, but we're gonna switch it to normal map. I see. And then we're going to select create from grayscale. And I'm going to deliberately lower this value to probably 0.34-ish, and then hit apply. I should probably magnify that if I haven't done so already. So here's what the values now read. Again, remember to set this to normal map. Then check the create from grayscale and set the bumpiness value to 0.034. And finally, at the very bottom, oh, I'm too zoomed in. At the very bottom, hit the apply button. Now you might be asking, hey Taro, what was the point of that? And I'll say, good question. There is a grass material right here, and you might notice that there is a field called normal map, which is what we just created, the texture type. So we can drag that normal map into normal map right here. And then if you look a little closely, okay, I guess that was too subtle, you might notice that our grass looks a little bumpier than usual. Yes, you can quote me on that, bumpier than usual. Yep. There we go. So that's like a really simple way of adding depth to your material. You can do the same thing for the rock as well. Just hit Control D on your rock JPEG file, and then switch that up to normal map, set to grayscale. This one I'm going to make it deliberately deep, say apply, select rock, drag and drop it to normal map, and look at that, that looks so much better. Also, it looks green. Look at that. I should quickly mention that, as with any materials, you can actually drag and drop them onto your cubes if you want to, which is going to create some really strange color combinations. There we go. So that's that. Normal maps is an industry-wide term for an image that represents the direction light is supposed to reflect off of a model surface. So if you're looking at this and asking a question of why is it weirdly purple, it's using what's called the RGB value. Each image has a red, green, blue value onto them. And it uses those values to indicate which direction on that surface it's supposed to reflect light from. So that's why it's able to create this bumpiness value, because any part of these like crevices right here, it's saying reflect it in a different direction than what you're normally supposed to, which is perpendicular to the surface itself. The model's UV coordinates will indicate how a normal map is supposed to be mapped on a model. It's usually exactly the same as the texture itself, so hey. Finally, we're going to play around with the lighting. This should be fairly simple. Since the light is already there, directional light, you just have to click on that. And I'm going to hit F so that I can actually see this. You can do a couple of different fun things here. You can obviously rotate it and create some night and dawn or whatever. I'm gonna make it. It's under the hierarchy, it says directional light. And then finally, you can also change the color. I'm gonna make it slightly more red. There we go. Make it a little closer to sundown. And you can adjust the intensity as well. You can also adjust the strength of the shadows. So if it's 1, then it's going to appear completely dark, but by reducing that value a little bit, it'll give a little bit of transparency to it. Yeah, just basically have fun with that and see what it looks like. Look at that. It's like sunset. The game. Also, please note, there's this button right here. It's actually very small. Let me zoom in. There is a button right here that if you uncheck, makes the thing look a lot more dull. So if for whatever reason this is what you see on your screen, make sure you check that. As you're playing around with that, real quick about the lighting. Lighting can be added through the game object field, as you can see from this screenshot. There are 4 actually different kind of lighting, but only 3 of those are based off of real time. That is the directional light, which is basically sunlight. Point light, which is a glow emitting from a single point. If you think of a lamp, for example, that's a without the lampshade. Then that's a really good example of a point light. And spotlight, which is basically a flashlight. It's a light that emits in a cone shape, versus a point light, which is all spherical direction. And finally, let's talk about actually building this executable. This can be done by simply going to File, Build Settings, and right now it has sample scene in there. We're going to get rid of that. Click on that and say delete. And we have Crash Course Unity scene right here. We're going to drag and drop that into the scenes and build. Alternatively, you can just hit add open scene and it'll automatically add that in. If for whatever reason you forget to delete the sample scene, you can drag the Crash Course scene all the way to the top and that will cause it to be the first scene to run. Finally, adjust the target platform to whatever platform you want to build to. Make sure you adjust the architecture from 64-bit or 32-bit. In this case, I want 64-bit. I should probably zoom in to make this clear. So you need to select whichever platform you want to pull it out for. Then right here under Windows, I have a Windows computer. I said I have a Mac. I'm on a Windows operating system. That's what matters. And then here it's 64-bit, so I want 64-bit. This is 32-bit, as you would expect. I wonder. Oh, it requires an SDK installed. Interesting. And you can honestly leave all these unchecked. Compression method, yeah, that's fine. And you can hit either build or build and run. They both do the same thing, except build and run runs the actual game. But I'm going to stick with build for now. And I'm going to put it in the projects folder. Well, I'm going to create a new folder, excuse me. We're going to call it Crash Course. And then select that folder. And there you go. You made your first game. Congratulations. Yay! We're gonna let it think. I know a few of you are still doing catch-up, but okay, here it is, by the way. Crash Course Unity. You can just double-click on the Crash Course Unity itself. Here it is. I'm going to window this and make it as small as possible. Wow, this is small. Oh, hey, you can hear the sound effects. Oh, I know what happened. Humbug. I muted the audio. There's a checkbox for muting audio. Now I know. But yeah, you can play the game as normal. Oh, this is actually a good point. There's save scene and there's save project. I would recommend clicking both of them, but save project has more to do with when you click on any of these objects or these files and you change any values in those inspectors, those meta files that were created on my folder earlier, it actually contains information of how things are imported. However, that is a separate operation from save scene. You'll need to hit save project to make sure that any import settings actually get saved. By the way, if you want to make sure, if you want it to be in my situation, like you have the meta file separate from the file itself, normally it's stored inside the library folder, then what you can do is you can go to edit, project settings, and mind you, this is completely optional. You don't need to follow along with this. I think it's editor. And then here under version control mode, most of the time it will say hidden metal files, but I usually prefer to just say visible metal files and leave it at that. There's a couple of other options, but I don't usually bother with playing around with that. That's under an inspector, by the way. Again, I'm gonna plug Unity's own tutorial website under unity3d.com/learn/tutorials.
How do you exit the game?
Huh?
How do you exit the game?
Alt Tab. If you're using Windows, Alt F4, excuse me. Alt F4.
For the Mac, it's Command Q.
Mm-hmm.
Is there a way to program in, obviously, like a user interface, like a menu bar, like a closed program, and things like
Yeah,
that?
so...
Obviously not tonight, but I mean...
No, let me go over it real quick. So earlier I talked about there's a reason why update exists. Here is me actually making update right now. If input dot get key get key up, and I'm going to make that key code escape.
So you the arrow key escapes.
Oh. Application dot quit. Quit. There. So what is this? Update runs every frame of the game. This is by saying void update, you're listening to that event. And then it's checking to see whether if you hit escape key. If you did, then quit the application. To be clear, this is optional. You don't have to follow this. But if I were to run this, if I were to build this again, excuse me, which I should be able to do it by just hitting build and run. When I hit escape, it should quit automatically. Let's make that a little bigger, because that was disturbingly small. There we go. Escape! There we go. That is it. I'm sorry that this took a few minutes longer. If you have any questions, feel free to ask them on the chat. I'll be here for a few more minutes. But ultimately, this is it. That's all I had. Yay!
Oh, okay. I was asking if I was would I have to build it again or would it be automatic? And I think you have to build it again to make changes, right?
Yes, if you make changes to the code, you will have to build it again.
And so these things you can build were lists: Macintosh, Windows, iOS, Android, Xbox.
Mm-hmm.
I mean, basically, you have Unity, you develop your app for your game, click build, it gives you the right file, and as long as you have different credentials with those places, you basically can publish. Is that correct?
Yes, correct. So in this case, for example, what it built was these information. By the way, if you, for example, I'm going to goof this a little bit. If you, for example, completely rename one of these files or delete them by accident, it's going to say, hey, there should be a Crash Course Unity data file in there. So when you're creating an installer from whatever software it is, or you're just bundling it into a zip file, all of these information, all of these folders and files are actually necessary. So keep that in mind. Macs are easy. It just creates a .app file, which is already a folder itself. If you drop into a Mac, you can just run directly off of it. Linux is the same story. It will create executables that you can run. You'll need to mark them as executables, by the way, because Linux is like that. But other than that, it'll create executables, but it'll also create these like extra folders, and those folders have to be in the same directory as the executable themselves. Android is really easy. Assuming you've set up all the signature stuff, you'll have to read the documentations on how to do that. But once you set up all the signature stuff, it'll literally just create an APK file, and you can just drag and drop that into your Android device, tell it to install it, and it'll play just fine. iOS, wow. iOS requires a Mac, and here's why. Macs are the only one that has Xcode. And what Unity does is it generates an Xcode project that in turn you need to open in Xcode and then build it. Wow.
So it hands it off to Xcode as its official Apple thing.
Yeah. I would definitely check both Unity's documentation and Apple's Xcode documentation on it. I believe Unity's documentation is thorough enough that the latter is not necessary per se, so that it'll automatically figure out how to configure the flags as necessary and so on and so forth. But just to let you know, there are documentation on it specifically. It is not as straightforward as I would like to admit. APK files actually, the signature part of it is not quite straightforward either. But once you set it up once, it's good. It's good. WebGL. WebGL depends on what web portal you're uploading it towards. So you'll need to contact their documentation and see what they require. But long story short, it generates an index.html file and a bunch of folders. You'll need all that information zipped into a single folder. You'll need an index.html on the root of that zip folder. So instead of like the normal way of just doing this and then saying zip by using send to, then compressed file, whoops, I didn't make that obvious. Send to and then compress, you'll actually have to highlight them like this and do the same thing. That way it will actually put the index.html in the root of that zip file. Yep. I have no idea for Xbox 360, PlayStation 4, or Switch because I don't have the license for either of those.
And the license for that is a Unity thing, or it's those manufacturers?
That's a good question. I don't know. I believe what you can do is you have to get the license from the manufacturer that you can build to that platform. Then you let Unity know via, I assume, their customer service, and then they'll give you the license. For most of these platforms, it's free. Once you get the platform license, once you get the platform or developer credentials, and you're able to supply that information, they'll send you that license for free. All right, that's it. Thank you very much for joining in our stream, and we'll see you next time.